Hello students, in this video I am going to answer to the questions of motion in a plane which are asked in AHS final examination, AHS first year final examination from 2023 to 2025 under Assam Higher Secondary Education Council. So before we solve this PYQs, and in this chapter also includes vectors as well. Okay. So before we start, please do subscribe to the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. So now let's start. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYAZIT123. that's my Insta ID. You can follow me on Insta as well. So now let's start. So here you see these three questions were asked in 2025. So let me answer one by one. Here you see this dot product of these two vectors is minus 12. Dot product of these two vectors is minus 12. We need to find the value of x. So let me show you how to solve this. So here it is given that 3i cap minus 2j cap plus 2k cap dot 2i cap minus xj cap plus 3k cap, that's equal to minus 12. So let's find the dot product. So 3i cap 2i cap 3i cap, that's going to be 6. I dot I is 1, so 6 into 1, right? Then minus 2 minus x, that's going to be plus twice x, right? J dot j again 1. Hope you know these things, that I dot I is equal to j dot j is equal to k dot k is equal to 1, and I dot j dot k and k dot I is equal to 0. Hope you know these things. So now let me show you how to solve this. So now you see again this 2k cap into 3k cap, that's going to be 6 into 1, that is 6, so minus 12. So now you see twice x, 6 plus 6, that's going to be 12 minus 12, and twice x, that's going to be minus 12 minus 12, and x going to be equal to minus 24 divided by 2, so x is equal to minus 12. That is the value of x, right? So hope you have understood this. Now what is the next question here? These two vectors are parallel. If so, when two vectors are parallel, then cross product of their magnitude is 0. Remember this. Okay, magnitude of the cross magnitude of their cross product is 0. Okay, so remember this condition. So which of the following quantities is a vector quantity? So here power is not vector quantity, energy is not vector quantity, density is not vector quantity. The momentum is the vector quantity, because momentum is mass into velocity, velocity is vector quantity, right? So that's why momentum must be also vector quantity. So now let's take the next question. So here find the scalar and vector product. We need to find both dot product and cross product. Scalar product means dot product, vector product means cross product. So hope you know how to find a dot product, as I have shown already. A dot b. So what is the vector A here? This 3i cap minus 5j cap plus 4k cap dot 2i cap minus j cap plus 3k cap. So now just give me a second. This is 2i cap. Okay, so let's find the dot product. How to find that? 3i dot 2i, that's going to be 6. I dot I is 1, so only 6. Then again minus 5 dot minus 5j dot minus 1j, that's going to be plus 5. J dot j is 1, again 5 on the 5, plus 4k cap 3k cap, that's going to be 12. K dot k is 1, so only 12. So now 11 plus 12, 23. So this is the dot product. Okay, so now let's find a cross product. In order to find a cross product, let me clean this, pause the video or take the screenshot of this or note it, okay, whatever you want. So now let me clean this to find the cross product. Okay, hope you have noted this. So how to find A cross B? A cross B. So here we need to take the determinant, right? Okay, first let me write the I cap, J cap and K cap. Okay, so first take the A vector. So what are the numbers before I cap, J cap and K cap? Let me write those. 3 minus 5 plus 4. Then take the B vector. So here what are the numbers? 2, here we have minus 1, then here 3. 2 minus 1, 3. If you want to find B cross A, then this second row should be first and first row should be second, right? Hope you have understood this. Now, so I cap. So how to find that? So now we know that first remember these things. I cross J is equal to K. J cross K is equal to I cap, then K cross I, K cap cross I cap, that's equal to J cap. Okay, remember this. So I cap is equal to J cross K. That's why for I cap we need to take this numbers below J and K cap, numbers below J and K cap. Okay, so first ignore this column. So below J cap we have minus 5, minus 1, and below K cap we have 4 and 3. So cross product should be started from this side, because I cap is equal to J cross K and J to K. So it's going to be minus 15, then again minus, then minus 1 into 4, that's going to be minus 4, but we have a minus here, so it's going to be plus 4, right? Then in order to find the J cap, here we need to take I cross K, because J cap is K cross I, you see, K cross I. So if you take I cross K, you should put a minus sign here. Okay, now you see, sorry, just give me a second. Okay, so here let me play this. Okay, now you see for J cross K, let me write here. Let me take the I cap. What are the numbers below I cap? 3 and 2. Then let me write K cap. Numbers below K cap 4 and 3. So J cap is equal to K cross I. K cross I. So here I am taking the I cap first. So that's why I have to put a minus here, because I cross K is minus J, right? So now you see, again start from here. 3 3 is 9, minus 2 4 is 8. Okay, then again plus K cap. So we know that I cross J is equal to K cap. So I cross J. So for K cap we need to take I and J, right? Let me cut this. Okay, sorry. So what are the numbers below the J cap? We have minus 5 and minus 1. Take this column. Okay, so when you are writing here K cap, ignore this column. Okay, numbers below K cap should be ignored. So now here 3 into minus 1, that's minus 3, and 2 into minus 5, that is minus 10, but we need to subtract these two, so that's why it's gonna be plus, minus minus plus 10 here, plus 10. This was minus 3. So now let's calculate. So minus 15 plus 4, that's going to be minus 11 I cap. Then 9 minus 8 1 J cap. Simply you can write J cap. Then plus 10 minus 3 is 7 K cap. So this is the answer, right? So hope you have understood this. So now let's take the next question. So here you see the position of a particle is given by this equation. We need to find the velocity along y-axis. Okay, so here position vector is given, r is equal to 3.0 t I cap minus 2.0 t square j cap plus 4.0 k cap. Now you see this is suppose x-axis, this is suppose y-axis, this is suppose z-axis. Similarly here in this direction we're gonna have negative y-axis, which is y dash, negative x-axis, which is x dash. Here it is negative z-axis, that is z dash. Now unit vector along x-axis is I cap, unit vector along y-axis is j cap, and unit vector z-axis along z-axis is k cap, right? And similarly along negative x-axis we're gonna take minus I cap, right? Similarly minus j cap means it is along negative y-axis, and minus k cap means negative z-axis, right? Hope you know these things. So now you see we need to find the velocity along y-axis, velocity along y-axis. So here, so this is the position in x-axis, this is the position in y-axis, and this is the position in z-axis. If you compare this r vector with this x I cap plus y j cap plus z k cap, right? So now as we need to find the velocity along y-axis, so we gonna find dy by dt. Okay, so here the y is equal to here minus 2.0 t square. Okay, so let us differentiate it. So derivative of this y, that is minus 2.0 t square with respect to t. So minus 2.0 is constant, that is taken out of the derivative, and derivative of t square, you know that ddx of x to the power n is n into x to the power n minus 1. So here instead of x we have t, and instead of power n we have power 2. So it's gonna be 2 into t to the power 2 minus 1. That means it is 2 into t, right? Minus 2.0 into 2t. So if you multiply this two, then it's gonna be minus 4t. So here this is in meter, this position is in meter, so we're gonna write meter per second here. So now you see this is the velocity. Time is not mentioned here, at which instant you need to find the velocity, so you need to keep it minus 4t meter per second. Okay, and if you write this in vector form, actually this is the y component of the velocity vy, right? This is the y component of the velocity vy jk. If you compare with that, that's going to be 4t minus jk actually, if you write in vector form. So that means it is along the negative y-axis. It is the velocity, direction of the velocity is along negative y-axis, right? So hope you have understood this. If you differentiate r with respect to t, then you will get actually velocity in this form. V is equal to dr by dt. So that's going to give you vx I cap plus vy j cap plus vz k cap. So here we are asked to find only this component vy. Okay, that is what we have got, right? So hope you have understood this. So now let's take the next question. So here it is asked pressure is vector or scalar quantity. That is scalar quantity, right? That is scalar quantity. So now this question is not from the 2D motion in a plane, so ignore it for the time being. Now draw a vector diagram to show that this is equal to this. So here it is, this is the associative property of vector actually. So now you see, suppose this is vector A, this is suppose vector A. Okay, so this is suppose vector A, and this is suppose vector B. Okay, this is suppose vector B, this is vector A, this is vector B, and let me take another vector, this is suppose vector C. Okay, this is suppose vector C. Now first you see the left hand side, A plus B. Okay, A plus B, then plus C. First let us find a resultant of these two. So you know, according to triangular law of vector addition, so these two A and B are in the same order, and if you complete the if you complete this triangle here, if you complete this triangle and if you take this side in opposite order, these two are in this order, A and B, and this is in opposite order like this. Okay, that means you can consider this one. This is a triangle, these two are in same order, and this is in opposite order. That is the order, you can consider that way, right? So if you draw these three vectors in this way, so these three are in same order, right? Hope you have understood this. So this vector is nothing but A vector plus B. Okay, then A plus B, then plus C, right? Plus C. So this is A plus B, then plus C. So that's gonna give you this resultant, right? So this, if you join this, if you consider this triangle, so these two are in the same order. Now if you complete this triangle and take this in opposite order, that's gonna give you A plus B, right? Then plus C. Okay, now we need to check the right hand side, A plus B plus C. Okay, now let's find B plus C. So here you see B plus C. So this is B plus C, right? This is B plus C. You see, this is B in this direction, and this is C. These two are in same order, and if you take this in opposite order, this is gonna give you B plus C, B plus C, right? And now you see, now take this triangle. You see, this is A vector, and this is B plus C. Now we have got this is B plus C. Okay, so then if you consider this, you can see clearly, if you again apply the triangular law of vector addition, these two are in same order and this is in opposite order. So this must be the resultant of these two vector A from this triangle. If you take this triangle, let me use another color so that you can recognize it clearly. So here you see this triangle, this green colored triangle, if you see this. So here this vector A is in this direction and vector B plus C is in this direction. These two are in same order, and this is an opposite order. So this vector is also, this is also A plus B plus C, right? So both, so here you can see these two, both left hand and right hand side represent the same vector. So that's why these two equal. So this is the figure. Okay, so now these questions are asked in 2024. So last question was, just give me a second. These two questions were asked also in 2024, right? So now here you see these are also asked in 2024. So here I am not going to solve this question because I will solve this question when I will explain the chapter for laws of motion. Okay, this chapter will be included in laws of motion. When I will make video on that chapter, then I will take this question. Okay, so as here acceleration is involved, so and mass and acceleration involved. So actually in kinematics, in 2D and in 1D motion, we don't used to discuss the force actually. So I'm gonna take it in laws of motion. Okay, so now let's answer this question. A projectile has an initial velocity v naught, okay, and angle of projection is theta naught. so that the range is this, horizontal range is this. So let me show this one. Okay, suppose this is the horizontal and a projectile be projected with initial velocity v0 at an angle theta naught. Okay, and it's gonna follow this path, it's gonna follow this parabolic path, and this is x-axis, and this is suppose range, that is maximum, that is the horizontal range. Okay, and this is suppose y-axis. Let me take this is y-axis. Okay, here is the y-axis, right? Now you see, okay, let me clean this. So here this v0 is the initial velocity, and theta naught is the angle of projection, with the horizontal. Right, now you see, so v0, this v0 will have two components. One is v0 x, so v0 x I cap, and v0 y z cap. We can write this way, right? So v0 x is, this component will be v0 cos theta, right? v0 cos theta, theta not only cos theta, and v0 y, this component, vertical component, that will be, vertical component will be v0 sine theta naught, right? And let me consider, so here it is, suppose origin, it is projected from the origin. So when t is equal to 0, the initial position, that means x0 comma y0 is 0 comma 0. Okay, 0 comma 0. And when the time, so let me write these things here, just give me a second. When the time, let me write here, t is equal to t, then its position is suppose x comma y. Let me consider that way. So after a time, this is the position at time, suppose x comma y. Let me consider that way. So now you see, x minus x0, that's going to be equal to v0 x. So we are trying to obtain the displacement along y-axis. So here we're going to take the velocity along y-axis, initial velocity along y-axis, v0 t plus half acceleration along x-axis, axt square. So acceleration also can be written in this way, ax I cap plus ay z cap. So here you see, let me tell you one more thing, acceleration here along the horizontal direction, there is no acceleration. Okay, it is only thrown once, then after that no force is acting along the horizontal direction, but in vertical direction there is a force of gravitational force. So that's why we're going to take acceleration due to gravity, as it is downward, so we're going to take minus z, right? So hope you have understood this. So now this y x0 is 0 because it started from the origin, so we're going to get x. Now here you see, v x0 is v0 cos theta naught, okay, into t. Since ax is equal to 0, so as ax is 0, so this term going to be equal to 0, we're going to ignore it. Okay, so this is suppose equation number 1. Now let's find the displacement along y-axis. So y minus y0. So in that case, we're going to take the initial velocity along y-axis, that is v0 y into t plus half ay t square, right? So again, y0 is 0, initial position is 0, so y is equal to v0 y, that is v0 sine theta naught, and minus half ay can be replaced by minus z. So this one, this is suppose equation number 2. So here we don't need this equation number 2. It will be used to find the horizontal maximum height, as we don't need maximum height here, so we are not going to use. If you don't write this step, then also okay, no problem, but this step is that is essential. It will be used later. Okay, now you see, let me go to the new slide. So here is the projectile. Let me draw it again. Okay, so this is the range R, right? So this is the x component, this is the y component, this is theta naught. Okay, so let me write all this. V naught x is equal to V naught cos theta naught, and V naught y, you don't need to repeat these things, V naught sin theta naught, as you have already written once. Okay, so don't repeat it. Just I have written so that I don't need to go to the previous slide again. Ax is equal to 0 and ay is equal to minus z. So I have already mentioned these things, but I don't want to go back to the previous slide frequently, so that's why I have written all these things. So what was the equation number 1? Equation number 1, we had got x minus x naught is equal to v naught x, displacement along x-axis t, plus half ax t square. So this term becomes 0, and x naught is 0. So equation number 1 was v naught x, that means v naught cos theta naught, that was the component along x-axis t, and this is become 0 because ax is equal to 0. This was equation number 1. So now let me take that time taken by the projectile to take this position, to reach this position, to complete the projectile, be suppose capital T. Capital T is the total time of flight. Total time of flight. Right, that is the total time of flight. Now at this position y coordinate is 0. At this position y coordinate is 0 and x coordinate is r. So if you take that equation, actually, okay, so we have to take if we take this displacement along y-axis, let me use that equation, v naught y t half ay t square. Okay, at this time, you see, so there is y is equal to 0, and here it was started from this point. So again reach the same level. So along the vertical direction, net displacement is 0 after time capital T, because it started from the ground and again reached the ground. So along the vertical axis, so displacement will be 0, and v naught y is v naught sin theta naught, and here time is capital T, then ay is minus z, so half minus z, and again capital T square, and from here we're gonna find t. Okay, from here we're gonna find the t. If you divide both side by t, then you're gonna get v naught 0 is equal to v naught sin theta naught minus half z and t, dividing both side by t, right? So if you divide this one by t, this one by t, and this one by t, so t cancels, right? 0 divided by 0, so 0 divided by anything is 0, right? So now this implies that half z capital T is equal to v naught sin theta naught, and that's gonna give you t is equal to 2 v naught sin theta naught by z. That's what we're gonna have. So this is suppose equation number 3. Now let me use this equation in 1. Okay, now at t is equal to capital T, x is equal to r. Okay, so therefore from equation number 1, x is equal to this, right? So we can write v naught cos theta naught, and now time is capital T, so we're going to put here T, capital T is equal to R. So here you see v naught cos theta naught, instead of capital T, what we're going to put, we're going to use this value. Okay, now hope you have noted these things. If you haven't noted, pause the video and note these things, because I'm going to clean this part. Okay, so now you see. Okay, so now let me clean these things. Okay. Now what we can do here, you see, if you replace this T by this value, then what you will get, so let me write this one here. Okay, we're gonna get v naught cos theta naught, instead of T we're gonna, so instead of this capital T, so we're gonna replace this capital T by this value, that is 2 v naught sin theta naught by capital V. On the right hand side we have R, right? So R is equal to, so here we will get v naught square, then 2 sin theta naught and cos theta naught by Z. There is a trigonometric identity, that is sin 2 theta is equal to sin theta cos theta, 2 sin theta cos theta. Okay, if we use that identity, then we're gonna end up getting v naught square sin 2 theta naught by Z, and this is the required expression, right? Here you see, this is the required expression that we have got. Now let me show you. This is the expression, right? Hope you have understood this. Now let me take the next question. So let me clean all these things, just give me a second. Okay, so we have another problem here. Okay, that is this one. So here you can see, so f and d, these two are given, and we need to find this ratio. So what is f here? F is equal to, the vector f is given, that 3i cap plus 4j cap minus 5k cap. Then vector d is given, that 5i cap plus 4j cap minus 3k cap. Okay, so these two vectors are given. So we need to find the ratio of f dot f by d dot d. So first let me find f dot f. Okay, f dot f. How to find that? So f dot f. How to find that f dot f? So you have to find the you need to find the dot product of f by itself. So again 3i cap, that means you need to take 3i cap dot 3i cap. So that's gonna be 9 into 1 i cap dot product of I cap and I cap, that's gonna be 1. So here we're gonna get 9, then plus again 4j dot 4j, that's gonna be 16, then minus 5k dot minus 5k, that's gonna be minus 25 k dot k 1. So that's what we're gonna have, right? Hope you have understood this. So if you add this 2, then you're gonna get 50. Now let's find d dot d. Again d dot d. So then 5i cap dot 5i cap, that's gonna be 25. Then 4j dot 4j, that's gonna be 16. And minus 3 dot k minus 3, that's gonna be minus plus 9. K dot k is 1, right? Again it's gonna be 50. So ratio of these two, f dot f by d dot d, that's gonna be 50 by 50. So it's gonna be 1:1, 50 cancels, right? So hope you have understood this. So let's take the next question. So a particle in uniform circular motion, what is the angle between the acceleration and velocity? Derive an expression for its acceleration. Let me derive it. So now you see, if a particle in a circular motion, suppose this is the circular path and here we have a particle. Okay, so this is the center of the path O, and radius of this path is suppose R. Sorry, circular path is R. So the direction of velocity at this position will be tangent to this circle, and this will be in this direction, and the acceleration will be directed towards the center. That will be called centripetal acceleration, and angle between this velocity and acceleration will be 90 degree. Okay, so here the answer is, okay, if a particle is in uniform circular motion, then the angle between its acceleration and velocity is 90 degree, right? Is 90 degree. That's the answer. So to derive this, let me take a new slide. Okay, so here you see this is the circular motion, circular path. Okay, so this is the circular path of center O, and here is the, suppose here is the particle at point A. When it is at point A, its velocity directed in this direction. This is suppose V. Okay, and after time del t, it reaches the point B, and here direction of velocity will be like this, okay, in this way. So this is suppose V dash. Okay, this is suppose V dash. Now this angle is suppose del theta, this angle is del theta. So here you see, relative to the origin, relative to the center, if we take position vector, this is suppose R vector, and this position is suppose R dash vector, and the displacement from this A to B will be given by this del R vector. This is suppose del R vector. Okay, so this is the direction of this position vector, and this is the direction of this R dash position vector, and the displacement from A to B, right? So first let me consider what I have considered here taken. Let me write what I have considered here. Suppose a particle is in uniform circular motion, moving with constant speed. Velocity will not be constant, velocity will be different, but speed will be constant, with constant speed, that is equal to V, along a circular path, with center O, and the radius of the path be suppose R. Okay, radius of the path be R. Okay, so now here let me take that R is the position vector with respect to the center O, position vector of A, point A, with respect to the center O, and R dash is the position vector of point B with respect to the origin O. So in exam, don't write this WRT. Instead of that, write in full form with respect to. Okay, so position, that R dash be the position vector of the point B. So del theta be the angle AOB. Okay, So and here you see del t be the time taken to cover the arc length AB, that is from A to B, from A to B. That means this arc, to cover this arc, time taken is suppose del t. Okay, now you see here this r vector, magnitude of r vector and magnitude of r dash vector both will be same. That will be r, that is the radius of the path. Because of the direction we are taking two vectors, but magnitude will be same. Similarly, as it is moving with constant speed, so magnitude of these two velocities v dash and v, so their magnitudes are same, but due to direction they are two different vectors, but magnitudes are same. V is equal to v dash is equal to here, that is v. Okay, so hope you have understood this. So now you see here what we're gonna do, that acceleration A, that gonna be equal to change in velocity del v by del t, del v by del t. I will write it later. First let me write something before that. So here you see, let me draw two more triangles here. You see, first one is AOB, this is AOB, this triangle. Here you see OAB, here this is r vector and this is r dash vector, and you see this is del r vector, right? Now if you apply the triangular law of vector addition, here you see these two vectors are in the same order, and resultant of the two vectors which are in the same order is given by the third side of the triangle which is in opposite order, right? So this is r dash, so sum of these two will be r dash. So that's why we can write that del r is equal to, we can write del r is equal to r dash vector minus r vector, right? This one on the other side. Okay, hope you have understood this. Similarly, now you see, hope you have the idea of vector shifting. We can shift a vector from one position to another position without changing the direction. Now suppose this vector is shifted to this position, suppose without any change in direction, it is v vector. Okay, so v vector is this. So let me draw here, this is the v vector, this is v vector, that is the velocity, and this v dash vector, it is also shifted to this position like this, suppose, okay, without changing the direction. So that is suppose v dash vector, that is the v dash. And let me complete this triangle as well. So this is gonna give you the change in velocity del v, this is gonna give you change in velocity del v. So this is the direction of v dash, this is the direction of v. Again here if you apply the triangular law of vector addition, you're gonna get del v is equal to then final velocity minus initial velocity. Final velocity means after the time t, del t. Okay, velocity after del t time, that's what I have taken, final velocity, and initial is v. Okay, so now you see here, let me give a name to this triangle, that is suppose O dash, A dash, B dash. So this angle will be also del theta, because you see, suppose you have two lines, this is suppose angle theta, and if you draw perpendicular here and here also, then angle between these two perpendiculars will be also theta. So that's why here you see this tangent to a circle is always perpendicular to the radius drawn at the center of at the point of contact. So this v vector is perpendicular to r vector, and similarly v dash vector is perpendicular to r dash vector. So that's why as the angle between r and r dash is del theta, so the angle between v and v dash must be also del theta. So hope you have understood this. Now let me copy these two small triangles and let me go to the new slide. Okay, so let me take a new slide so that I can explain further. Okay, now you see from these two triangles, okay, here we can say that OA and OB, these both are equal to radius r, right? And this O dash B dash, O dash, sorry, not B dash, O dash B dash and O dash A dash. Okay, so since magnitude of V and V dash equal, though V and V dash are two different vectors, but their magnitudes are equal, that is V, I have already mentioned. Similarly, so let me write here V. Similarly, OA, OB, these two represents two different vector R and R dash, but their magnitudes are same. Okay, that is equal to R. So we can write this way, right? Hope you have understood this. And similarly, angle in these two triangles, these two angles AOB, this angle AOB, angle AOB is equal to angle this in this triangle A dash O dash B dash, this angle A dash O dash B dash, A dash O dash B dash, these two are also equal to del theta. So according to side similarity, side angle side similarity criteria, these two triangles A dash O dash B dash must be similar to AOB, because you see, let me tell you something, because you see, if you divide this one by this one, then what are you gonna have? OA by O dash A dash is equal to OB by O dash B dash is equal to R by V. Okay, so here two pairs of sides, corresponding sides of these two triangles are in proportion, right? So and you see two sides, two pair of sides are in proportion, and angle between them are also equal. Angle between those two pairs are also equal. So that's why according to side angle side, these two triangles are similar. If these were similar, then we can say all the three pairs of sides of these two triangles must be in proportion. That means we will get OA by OB, sorry, not OB, OA by O dash A dash is equal to OB by O dash B dash is equal to, then we're gonna get A dash B dash, AB by A dash B dash, AB by A dash B dash. That's what we're gonna have, right? And so you know this 2 is equal to R by V. From this equation we get R by V. On the other hand, AB by A dash B dash, this is AB, that is del R, and A dash B dash is del V. So when you take the length of the sides, then you need to take the magnitude of the vector only, that is del R, magnitude of del R and magnitude of del V, right? That's what we're gonna take. So hope you have understood this. And this is equal to, so from here del R is equal to, we're gonna get R by V into del V. That's what we're gonna have. Now let me go back to the previous slide. Here you see this acceleration is average acceleration. Actually this is average acceleration. So if you take the limit del t tends to 0, then you're gonna get the instantaneous acceleration, right? So instantaneous acceleration, let me write here, instantaneous acceleration, that's gonna be equal to A is equal to limit del t tends to 0 del V by del t. As it is directed, So that's gonna be also equal to dv by dt. Okay, as it is directed towards the center, as it is directed towards the center, so it is called centripetal acceleration, right? So we're gonna write AHSEC is equal to limit del v by del t tends to 0. Okay, so now let me copy this expression and let me go to the next slide. Here you see this is the expression for instantaneous acceleration, right? Let me take this as equation number 1. Okay, now you see what we're going to do. Let us divide this equation both sides by del t, and you don't need to write this one again if you have written in previous you written already. Okay, this was I have written this one from the previous slide. Okay, so that should be written before this part is started. Okay, so now you see take limit on both sides. Okay, so just give me a second. Okay, so let me write these things here. So here you see what we have done. Let me divide it by del t on both sides. Okay, on both sides del t. Then let me take limit on both sides. Limit del t tends to 0. On the left hand side also limit del t tends to 0. Then you see this one will be del r by del t, and limit del t tends to 0 means this is dr by dt, right? Dr by dt, as we are taking magnitude, so we don't need to write this arrow sign. Okay, so dr by dt, that means nothing but velocity v, right? Again r by v, here you see. Now you see, so we have taken this part outside the limit because this radius is fixed and v is fixed, but they're not gonna change with the time, so that's why. Now you see, compare with this one. Okay, so this can be replaced by AC. So this can be replaced by AC. This time don't give this arrow sign because so here we have taken the magnitude of change in velocity, not the change in velocity, magnitude of that we have taken only. So we're gonna remove this vector sign if you write here modulus, right? Hope you have understood this. And this implies AC is equal to v square by r, and this is the required expression for acceleration of the particle which is in the circular motion. Okay, so here you have to write, since AC is equal to limit del t tends to 0, limit del t tends to 0, del v by del t, mod of del v by del t. Okay, we have used this one here. Okay, so hope you have understood this. So this is the required relation. So now let me take the next question. So these two questions were asked in 2023. Magnitude of I cap and j cap, the magnitude of the resultant of these two has the magnitude root 2, then what is the angle between I and z? That's obviously 90 degree, because you see here the resultant of this I and j, the magnitude of the resultant of these two is given root 2. That means you see magnitude of these two by cosine law, it will be given by magnitude of I is 1, magnitude of j is also 1, plus 2 1 into 1 cos theta, that's going to be equal to half, right? We know that resultant of two vector a plus b and its magnitude r is equal to its magnitude resultant magnitude of the resultant vector is given by root over a square plus b square plus 2ab cos theta, right? So we know these things, so we have used this one here. So but angle between I and J, that's obviously 90. Actually we don't need to do that, but okay, let me show you then. Squaring both sides, we're gonna get here 1 square, that's gonna be 2 plus 2 cos theta. So here on the right hand side also 2 after squaring. So after squaring both sides we have got this, then 2 cos theta is equal to, that is equal to 0. So cos theta will be equal to 0. We know that cos 90 is 0, cos 90 is 0, so that's why theta is 90. So that is the angle between I and J, that is 90 degree. So now name the projectile motion in which range doesn't depend on initial velocity. That will be vertical projectile. Okay, in vertical projectile doesn't matter what is the initial velocity, the range always going to be equal to 0, right? So the answer should be vertical projectile. Right, so now let me take the next question. SI unit or product of force and velocity gives power P is equal to F dot V, and the SI unit of power is what? Okay, so now let's take the next question. So the magnitude of the resultant of two vectors A and B, angle theta between them. So the magnitude will be given by R is equal to root over A square plus B square plus 2AB cos theta. Okay, to obtain this, let me use the triangular law of vector addition. First let me clean this. Okay, so now you see, suppose this is vector A and this is vector B. Suppose this is vector B, so let me draw the vector here. Just do one thing. So this is the vector B, so this is the head of A, this is the head of B. Okay, so then the resultant will be given by, let me use another color, will be given by this third side of this triangle taken in opposite order. That will be the resultant of A and B, that is A plus B, which is equal to R, right? We need to find a magnitude, and let the angle between the two vectors A and B, the angle should not be taken here, that should be taken here, because we're going to take the angle between two vectors, that will be always angle between the direction actually. Okay, so when these two vectors are drawn in this way, then you can consider this angle, but when this vector is here, then you have to consider this angle, okay, not this one, right? Hope you have understood this. Now you see, just give me a second. Okay, so now you see, let me take this angle is theta, and let me draw a perpendicular from this point. This perpendicular is suppose N. Okay, this perpendicular is suppose N, and this triangle is O P, and this is Q. Okay, to give the answer, let me erase this question. Okay, so this was asked in 2023. So now you see, let me consider that two vectors A and B are represented by two sides of a triangle. So here I have considered that these two vectors A and B are represented by OP and PQ respectively of triangle OPQ. Okay, and the resultant R vector is represented by, so let me write it properly, and the resultant R vector, which is equal to vector A plus vector B, is represented by the side OQ, right? Hope you have understood this. So here the length of OP gives magnitude of vector A, and length of PQ will give the magnitude of vector B, and simply you can write A, and you can write magnitude of vector B, simply you can write B. Okay, and OQ represent the R. Okay, and angle between these two vectors is theta. So let us take theta is the angle between two vectors. Okay, then Qn is perpendicular to extended OP extended. Okay, so now here you see from the triangle, now from this triangle QPN, from this triangle QPN, this angle is theta, right? Angle QPN is theta, right? So from here what we're gonna get, sine theta is equal to, so sine theta will be equal to Qn by Pn, right? Perpendicular by, sorry, Qn by PQ, Qn by PQ, Qn by PQ, Qn by PQ. So that's why what we gonna write, PQ is nothing but the magnitude of B, right? So simply you can write B. So sine theta is equal to Qn by B, which implies Qn is equal to B sine theta. Qn is equal to B sine theta, right? Now cos theta from the same triangle will be Pn by again PQ based by hypotenuse, right? And Pn by PQ is nothing but PQ, again this is B, right? So that's why Pn is equal to B cos theta, B cos theta, right? B cos theta. So now you see from the triangle, this bigger triangle QON, from the triangle QON, so if you use the triangle, if you use the Pythagoras theorem from triangle QON, what we're gonna get, OQ square is equal to ON square plus QN square. Now you see this ON can be written as sum of, here we have point P, suppose sum of OP and ON, right? You can see clearly sum of OP and PN gives the ON, right? So that's why this ON can be written this way, OP plus PN gives whole square of OP plus PN gives ON square. Then again we have QN square here plus QN square. So instead of ON we have written this. Okay, so now let me take a new slide. Let me take, this is equation number 1, this is suppose equation number 2. Okay, so if we use these two equations 1 and 2 here, so OQ is nothing but R, right? So we can write it like this way, just give me a second. So OQ is nothing but R, so R square. So instead of OP, so squaring this, what we're gonna get, OP square plus 2 OP into PN plus PN square, right? So OP can be written as where is OP? This is OP, this is nothing but magnitude of A, right? Plus 2A, this is 2OP, then Pn can be replaced by B cos theta, right? B cos theta. Then Pn square, so we're gonna get B square cos square theta. Then plus we have Qn square. So now let me copy this last step and let me take a new slide. Okay, so here let me write using 1 and 2, using 1 and 2. Okay, so this is the last step we have got. So therefore from here A plus and Qn, if you see the diagram, let me go back to the previous slide. You see this Qn can be replaced by B sine theta. So instead of writing Qn here, let me write B sine theta. So B square sine square theta. Okay, so Qn is replaced by B square sine square theta. So this, instead of Qn square, we should write B square sine square theta, right? So hope you have understood this. Now from these two we can take B square common. So B square sine square theta plus cos square theta. So let me write it properly. 2ab cos theta. So here B square is taken common. We have got cos square theta plus sine square theta. So this is gonna give you 1. So what are you gonna get? So it's supposed to be a square. Sorry. So here you see this on square. So it's supposed to be a square. On is a. So now r will be equal to root over a square. Let me write b square. Then 2ab cos theta. Right. So that's how we can obtain the magnitude. So now let me take the next question. Now you see, this is the next question. Prove that the law of cosines and cosines of vector addition also derive the law of sines. So you see, law of cosine means this equation that now we have shown already. R is equal to that a square plus b square plus 2ab, and then we need to show law of sines as well. So in order to show that, let me use the parallelogram law. Okay, here you see, suppose this is one vector, this is another vector, this is vector A, and this is suppose vector B, and now let me complete the parallelogram. Okay, so this is vector A, this is vector B, then the resultant will be given by this diagonal. Okay, from the same origin, from the same initial point. This is the R, right? So now let me draw a perpendicular here. Okay, this angle is theta, as the angle between these two vectors A and B is suppose theta. Okay, then this is corresponding angle, that's going to be also theta. This is suppose O, P, Q and S. This is suppose Qn, and let me draw another perpendicular here. This is suppose let me take this is M. This point is M. Okay, right? Hope you have understood this. So, and this angle, let it be this, let this angle be alpha. Okay, this angle made by the resultant with vector A, and the angle made by the resultant with vector B is suppose beta. Okay, this angle is beta then. Okay, right? Hope you have understood this. Now let me write what I have considered here. So here I have considered these two vectors A and B are represented by these two sides respectively, OP and OS. Okay, as shown in the figure of this parallelogram OPQS, right? So here angle POS, which is equal to theta, is the angle between the two vectors, vector A and vector B, right? And the resultant of vector A and vector B is represented by the diagonal OQ. Okay, so here OP will be equal to magnitude of vector A. That means you can write simply A, and OS, which is also equal to OQ. OS this side is also equal to PQ, not OP, PQ. That is nothing but that will represent magnitude of vector B. That means simply P. and the length OQ will represent the magnitude of vector R, that is resultant vector. So simply you can write R, right? So here QN is perpendicular on extended OP extended, okay, and this QN, this one here you can see, okay. Then PM is also perpendicular to OQ, diagonal OQ, right? And the angle between, so here alpha is the angle between resultant and vector A, and beta is the angle between the resultant and vector P, okay. So hope you have understood this. So pause the video and note. Now let me take a new slide, okay. I will redraw the diagram again. So here is the diagram, okay. Now let me consider this triangle QPN, okay. So from this triangle QPN, what we can write from triangle QPN, so we can write sine theta is equal to, sine means this QN perpendicular by hypotenuse PQ, okay, QN by PQ, okay. And here this length PQ will represent the length of vector B, that means the magnitude of vector B. This side also represent B, and these two are opposite sides, OS and PQ are opposite sides, and in case of parallelogram, opposite sides are parallel and equal. So if OS represents a vector B, this OS represents vector B, then PQ must represent vector B, okay, and their length will give the magnitude of this of the vector B, right? So hope you have understood this. So we can write this as QN by PQ, which implies that we can write QN instead of PQ, we can write magnitude of vector B. So simply you can write B. So QN is equal to B sine theta. This is suppose equation number 1. And similarly, from the same triangle, if we find cos theta, then we're gonna get cos theta is base by hypotenuse, so Pn by PQ. This is Pn by PQ, right? This is base, this is hypotenuse, right? Hope you have understood this. So we can write Pn by PQ. Again, PQ is replaced by B, Pn by B. So therefore, we're gonna get Pn is equal to B cos theta. This is suppose equation number 2. Now let me take this triangle OQN, okay. This triangle OQN. From this triangle, what you can do first, let's apply the Pythagoras theorem. From triangle OQN, from this triangle OQN, right? Hope you can see this triangle clearly. This just give me a second, let me show you this triangle, this OQN, this triangle. I am talking about this triangle, right? So here you see OQ square, hypotenuse square, is equal to perpendicular square plus base square, right? So here base is ON and perpendicular is QN, so ON square plus QN square, okay. Now you see QN represents the resultant vector, so that's why here we're going to write R square. And ON, this ON can be written as OP plus PN, as you can see from the diagram clearly, right? So OP plus PN gives ON, right? So we can replace ON by OP plus PN whole square. Then QN, this QN is, so I will replace this later, let it be QN for the time being, QN square. So now R square, let us apply here A plus B whole square. Then what we're going to get, OP square plus 2 OP into PN plus PN square plus QN square. Now you see this OP, this is the OP, which is nothing but magnitude of vector A, right? And PN is this one, PN this one, and from here we can write B cos theta, right? And QN, this is QN, which is equal to B sin theta. So let's put those, let's use those results. Okay, so then using these results, what we're gonna have, so R square, OP is nothing but A vector, so OP square is A square, then 2A, instead of OP we have put A, then PN, instead of PN we're gonna put B cos theta, so B cos theta, this PN is replaced by B cos theta, then again PN square, that means B square cos square theta, then this QN will be replaced by this B sin theta, right? So here we have QN square, so B square sin square theta. So using 1 and 2, using equation number 1 and 2, right? That's what we have got. Okay, so now what we are going to do, first let me clear this, just give me a second. Okay, let me simplify this. So let me simplify this. Okay, so here you see R square is equal to, from these two terms we can take B square common, right? So A square plus B square, after taking B square common from these two terms, we're gonna have here cos square theta plus sin square theta, right? Then let me write this term, plus 2AB cos theta. So that means R square is equal to A square plus B square plus this become 1, 2AB cos theta. So this is the laws of cosines, laws of cosines, and this implies R is equal to root over A square plus B square plus 2AB cos theta. Okay, so this can be written this way, right? If you take the square on the left hand side, taking square root on both sides, that's what we have got. So this is the laws of cosine we have already got. So now let's find the laws of sines. Okay, so let me go to the next slide, and first let me copy these two equations. Okay, I'm gonna need these two equations. So first, so these are the two equations, and let me draw the diagram as well. Okay, we need the diagram also. Now you see what we're gonna do here. You see, so first let me take this triangle. First let me take this triangle OQN, this triangle. Okay, from the triangle OQN, so let me write here, so OQN, this is alpha. Okay, so from this triangle what we're gonna get, sin alpha from triangle OQN. Okay, sin alpha, we're gonna get QN, that is perpendicular by hypotenuse OQ, right? So OQ is nothing but the resultant R, so we can write QN is equal to here QN by R. So Qn is equal to R sine alpha. That's what we can write. And we know that Qn is equal to B sine theta as well. So let me replace this by B sine theta. Okay, using one, B sine theta is equal to R sine alpha, using equation number 1. Using equation number 1, right? And this implies R by sine theta. If you simplify this, then you're gonna get B by sine alpha. Let it be equation number, suppose 3. Let it be equation number 3. Now let me take this triangle OPM, this triangle. Okay, triangle OPM. Let me take this triangle. So from this triangle, here you see this is the right angle, so that's why this OP is the hypotenuse here, and this PM is the perpendicular, right? Hope you can see the triangle clearly. Let me draw here, just give me a second. Okay, so now let me draw the triangle OPM. Here is the triangle OPM. This is M, this is P, this is O. This triangle, right? Here this angle is alpha. So this is gonna be the hypotenuse, this is gonna be the perpendicular, right? That's gonna be the base. Okay, so from triangle OPM, here sine alpha is equal to perpendicular PM by hypotenuse OP. Okay, and OP is nothing but this represent vector A, so its length will be equal to magnitude of vector A, right? So PM by A, so which implies that PM is equal to A sine alpha, right? PM is equal to A sine alpha. This is suppose equation number 4. Okay, so now again let me take this triangle, here you see PMQ, okay, PMQ, this triangle. So here this angle is beta. Okay, so if you take that triangle, then what you're gonna have, let me clean these things. Okay, let me clean the diagram a little bit. Okay, now you see, just give me a second. Okay, now let me draw the diagram here. That is PMQ. Okay, here is the diagram. It's something like this. This triangle PM, which is the right angle here, Q, and this angle is beta. So that's why this is the hypotenuse, which is opposite to the right angle, and this is the perpendicular. So sine beta from this triangle, from triangle PQM, sine beta is equal to, that is perpendicular PM by hypotenuse PQ. So here PQ, this side PQ, this side PQ will again represent the length of vector B. So because OS represent vector B, then PQ also represent vector B. So its length gonna give you the magnitude of vector B. So we can write PM by B. Okay, so that implies PM is equal to B sine beta. Okay, B sine beta, right? So now we have got that PM is equal to A sine alpha, so we can replace this PM using equation number 4. So here we can write that A sine alpha is equal to B sine beta, right? B sine beta. So, and this implies that a sine beta is equal to b sine alpha. So this is equation number 5. Let me copy the equation number 3 and 5 and let me write on a new slide. Okay, you don't need to write it again, don't repeat it, just as I have changed the slide, so let me write again. Okay, so this is equation number 5. Here you see these two equations. From these two equations you can see clearly that these two are equal, and so these two must be also equal. So that's why here you see this one is equal to this one, and this one is this, and this is equal to this one. So all the three ratios must be same. So from 3 and 5, what we're gonna get? We're gonna get sine r by sine theta, that is equal to a by sine beta, that is equal to b by sine alpha. So this is what we have got, right? So this is the law of sines. Okay, so hope you have understood this. Now let me find the angle between the resultant, and that means let me find the direction of the r vector. Okay, let me find this direction of this r vector, this vector. So let me copy this diagram as well. So let me copy this diagram. So let me paste here to find a so to find the direction, actually we need to find this angle alpha. Okay, so now you see, so from here again, just give me a second, let me copy this diagram. Let me draw it here. So now let us take this triangle OQN. Okay, let me take this triangle OQN. Okay, from this triangle, from triangle OQN, here you see tan theta, sorry not tan theta, tan alpha, that's going to be equal to QN is the perpendicular and ON is the base. So we're going to write QN by ON, and ON can be written as OP plus PN, right? So now you know that OP is nothing but magnitude of vector A, so tan alpha is equal to, and QN in equation number 1 we have got QN is equal. So here you see this is QN. Okay, let us put QN sine theta, and here let me put this QN is equal to b sine theta. Okay, so we can replace QN by b sine theta, and OP is nothing but A, and PN, so from equation number 2 PN is equal to b cos theta. So let me put here b cos theta. Okay, again using 1 and 2, using 1 and equation number 2. Okay, so therefore alpha is equal to tan inverse b sine theta by A plus b cos theta, right? So this angle is made with vector A. So this is going to give you the direction of the resultant vector. Okay, and this is the angle, so here we can write is the angle made by the resultant vector R with A, which gives the direction. Of R vector. Okay, so hope you have understood this. Now let's move on to next question. Now what do you mean by equality of vectors? Okay, so let me write here answer to question number this question, answer to this question. So two vectors are said to be equal if they have the same magnitude and direction. If they have the same magnitude okay, and the direction okay, then two vectors will be called equal vector. Okay, then draw a vector which is equal to vector 3a. So if there is a vector a, so suppose this is a vector a, next part is if a is a vector, then draw a vector which is equal to 3a. So this is, if this is vector a, then 3 times of vector a will be equal to so you have to draw an arrow which is 3 times longer than this vector. So if you have drawn this one 2 centimeter, you have to make a 6 centimeter line like this, and that should be directed in the same direction, right, as a vector, and this must be equal to this must be equal to 3 times of this vector, right? So a vector, this is 3 times of, this is 3a. Okay, so that means its length is 3 times of vector a, right? So this part is suppose a, this part is suppose a, this part is a. Okay, that means this total length must be 3a, right? Hope you have understood this, right? So that's how we need to draw. Now you know that the range of an inclined projectile is expressed as given below. This is the range of an inclined projectile, where v0 is the initial velocity and theta naught is the angle of inclination. So what is asked here from the expression, so that the range in case of vertical projection. So in case of vertical projection, for vertical projection, in case of vertical projection, this theta naught, angle of projection, that must be equal to 90 degree. Okay, therefore range will be equal to v0 sine 2 theta naught means 2 into 90, okay, divided by g, and v0 is square, 2 into 90 means 180, okay, by g. Okay, sine, value of sine 180 is equal to 0, so that's why the range is going to be equal to 0. That is the answer. Okay, so you have understood this. So that's all for today. Thank you for watching. See you in the next video. Bye bye.